Okay, let's apply my method or strategy or tips to 2019. And these questions should be a little bit more familiar to you because I think you did quite well when you were doing these types of questions. So number one, look for an equation. We have v is equal to at squared plus bt plus c. There's my equation straight away. The velocity on the left is dependent on the time. Remember that the velocity is dSdt, the rate of change of displacement with respect to time. So for me, the variables here in that equation are v and t. The constants are a, b, and c, which is given in the line as well. But if you put in ds dt for v, then the variables become displacement and time, and the constants are still a, b, and c. Okay. Does it represent growth or decay? Well, the velocity is related to t squared and t, both of which are positive from what we can gather from that equation. So it looks like it's going to be growth. Okay, so that means the speed is probably going to increase. Well, it's not the full picture, but we'll see in a moment exactly what's going on there. Okay, I've identified the variables and constants. I've identified whether it's growth or decline. We have our equation, so let's have a read down through it, because we can't really do much more with that velocity equation other than say that the velocity changes with respect to time. Okay, so a particle p moves along a straight line. The speed of p at time t is v, where v is given by that equation. A, b, and c are constants. Okay, the initial speed is 15 meters per second. That means that when t equals 0, the u value, or the velocity when t equals 0, is equal to 15 meters per second. And then we're told after 2.5 seconds, the particle reaches a minimum speed of 2.5. So when t is equal to 2.5, we'll have the smallest v value. The minimum is in bold specifically because we know that if we differentiate that function and leave it equal to 0, that's the minimum of the function. So dv dt is the acceleration, and when we get dv dt and leave it equal to 0, we know that occurs at 2.5. We also know the acceleration is equal to 0. All right, so let's see what we're looking for, A, B, and C. So let's apply the initial conditions. If t was equal to 0, v is equal to 15. If you sub those into the formula, v is equal to at squared plus bt plus c, that will give you a c value. So that's the c value done. The next line then must be used to get b and c. So what I'm thinking of is, first of all, after 2.5 seconds, the speed is 2.5. Sub those in, and you'll get an equation with a, b, and numbers in it. And the second thing is we're told about a minimum speed. So if you differentiate that function and leave it equal to 0, you'd have 2at plus b equals 0, and that occurs after 2.5 seconds. Put in your 2.5, you have a second equation for a and b. Solve those simultaneous equations to get a and b. Okay, that's one done. Part 2, find the acceleration. So we know to differentiate v to get the acceleration, and we're looking for the acceleration when t is equal to 4. Get your acceleration function, sub in 4, job done. That's a maths question, gents. You should be able to do it from Leaving Cert Higher Maths. The third one is find the distance travelled in the third second. So remember that the velocity is ds dt, where s is the distance or displacement and t is the time. So if you let ds dt equal at squared plus bt plus c and integrate it to get s, that would give you a formula that you can use for part 3. Now, the only thing that's unusual there is the time in it. So the third second is actually the time between the second and the time between t equals 2 and t equals 3. So recall or remember that the first second is between time 0 and 1. The second is between 1 and 2. So the third second is between 2 and 3. And to get the distance in the third second, you'd have to get the distance travelled in 3 seconds and subtract off the distance covered in 2 seconds. All right, pause the video, go away and do it. I'm going to go on to part B. All right, let's look for a differential equation. Now, there's an equation there, all right. It says show that v is equal to that. So that's what we're looking to show, but it's not a differential equation. That means we're going to have to go to the text and see can we get a differential equation from it. Start with the first line then. Particle of mass m falls vertically downwards. You need to draw a box. If it's got a mass, it's got a weight, so mg is the force acting downwards on it. At time t, the particle has a speed v and it experiences a resistance force of magnitude kmv. So on your box, there'll be an upward force of kmv, and the acceleration we're going to assume is downwards. If you apply F net is equal to ma, that will give you an equation for the acceleration. And what we're looking to do is not get an acceleration formula, but get a velocity formula. And in particular, in part 1, we're looking for a formula with v and t in it. So you need to leave a equal dv dt. And the fourth line there tells us the initial speed of the particle is u. So when t equals 0, v equals u. And then when t equals t, v equals v, you should be able to integrate and work out your equation. So this is stuff we did a couple of weeks back, and hopefully it's a bit easier than the 2020 question. Part 2. If u is equal to that and k is equal to that, find the distance travelled by the particle in 4 seconds. Now, you can go back to the acceleration formula, but right now I don't recommend you do it. I recommend using the formula in part 1 to get part 2. And I do that because they're giving the formula in part 1 in case guys can't do it, but also because it's likely that it's easier to integrate. So multiply in by the e to the minus kt, and then leave v equal to ds dt, get a formula for s, and sub in for the values there if you can, and see how you get on. Now, as I say it, and as I read the question, I'm noticing that it might actually be easier to go to the acceleration formula and do it. But look, try both ways and see how you get on. Pause the video, go to the marking scheme afterwards, and I'm going to go to the next year. So 2018, let's have a go. We've done this one already. So first thing, is there a differential equation there? There is. It's a vibration on a vibration. So dy dx is 3 sine 3x, and then there's another vibration, cos 5x on top of that. Okay, so we have those. We have a set of initial conditions. Y is 1, x is pi over 4. And we have find y when x is pi over 2. This should be very straightforward. So integrate it. Get y on its own on the left, x on its own on the right. Sub in your initial conditions to get the constant value. And then sub in your second conditions to get the y value. Do we need to do any of the rest? Probably not. But I am going to go through what the variables and constants are in this case. Excuse me. If we look at the derivative on the left, dy dx, there's a y and an x. They're the variables. So y and x are variables. Everything else is a constant. In the case of the right, the x's are variables, and those x's are contained within the sine function. So when we integrate, we have to integrate sine of 3x and cos of 5x. We can't just integrate the x and the 5 because they're under the operation of sine and cos respectively. The constants are numbers, so that should be okay. All right, does it represent growth or decline? Both, actually. So a sine function is like a wave, goes up and down. Cos function is like a wave, and like I said here, it's a cos function stacked on top of a sine function. So it's a wave that looks like 3 sine 3x, but instead of being a smooth curve, it's got a wobble traced out on that curve, and that wobble is given by cos 5x. Vibration on a vibration, basically. Okay, so what's happening? As x changes, the y value changes, and it's as a constant increase and decrease and increase and decrease. It's simple harmonic motion. Pause the video, do it. I'm going to go on to part B, and then we'll call it a day with the end of this video. Okay, so this is the emigration one. First thing we need to do, look for a differential equation. Is it given? Yes, it is. Second thing, does it represent growth or decline? So it's dx dt on the left. X is the variable we need to look for, and we're looking for a plus or a minus in front of the x. It's a plus, so it represents growth. Okay, what are the variables and the constants? Again, we look at the left-hand side. X and t are the variables. Everything else is a constant. So n is a constant. Okay, so let's have a look at what's going on. It's a population increase model, so dx dt is equal to x over 40. So that's telling us the population is increasing. But there's a minus n on it. And what that's telling me then is there's going to be n number of people leaving the country for every unit of time. So for every 1 second or 1 month or 1 year, depending on what unit really is given in the question. So it says the rate of change of the population is equal to the number present in the population divided by 40, but we're always going to lose people for every unit of time, and that's given by the n value there. That's my interpretation. Let's read the question. It starts off, if there were no emigration. Now that doesn't agree with my differential equation straight away, because n tells me there's people leaving. Okay, if there were no emigration, the population X of a certain country would increase at a constant rate of 2.5% per annum. Okay, fine. If we were doing that, we'd probably use dx dt is equal to kp. And then when t is equal to 0, we might say the population is p0. When t is equal to 1, the population would be 1.025 of p0. And you could get the k value there. But then it says, by emigration, the country loses population at a constant rate of n people per annum. So what I said is correct. We're losing people at n people per unit time, per annum in this case. And that's why there's a minus n after it. That tells me that the first sentence, the information there, it has no relevance to the question. Okay, it has no relevance to the question because the formula used to calculate the 2.5% per annum is not the formula used when emigration takes place. All right, so we've inspected everything to do with my 4 tips. Then we read it line by line. We read it sequentially. And from that, we can see there's conflicting evidence, but my equation identifies that the second sentence is the one that's legitimate for this question. Okay. If initially the population is p people, find in terms of np and t the population after t seconds. So when t is equal to 0, the population is p. So when t is equal to 0, x equals p. And then when t is equal to t, x equals x. And we're looking to get a formula for x. And then, given that n is equal to that, p is equal to that, find t when the population is equal to that thing there. So I'd imagine that you're going to get the answer from question 1 and just sub in those values and get a t value from it. And I'll do what that question look, and I'll post it in a separate video. But pause the video, or this is the end of the video even, do the question before you look at that video, please.